Hello and salam sejahtera. I'm Jana Ibrahim. This video is about BJT Common Emitter Amplifier circuit. In this video, we will discuss how to do AC analysis of amplifier circuits. After watching this video, we should be able to describe gain and types of gain associated with common emitter configuration. We should also be able to derive the AC equivalent circuit for a given amplifier, calculate the voltage gain, current gain, and power gain, and explain the relationship between the load resistance and voltage gain of a CE amplifier. The AC characteristics of a common emitter amplifier are demonstrated using its equivalent circuit. The equivalent circuit is also used in many AC calculations. It is derived using these two steps. First, short circuit all capacitors, and second, replace all DC sources with ground symbol. It is very important to remember that the AC equivalent circuit represents the AC characteristic of the amplifier, and it is not used in the DC analysis of the circuit. Note that the input-output relationship of the common emitter amplifier is unique, as its input and output signal voltages are 180 degrees out of phase. To understand the phase relationship between input and output voltage waveforms, 2 points need to be considered. First, the output circuit is taken from the collector and it is measured with respect to ground. Therefore, Vout is equal to Vc. Secondly, the collector voltage is equal to the supply minus the drop across the collector resistor. This is expressed by Vc is equal to Vcc minus IcRc. Remember that for the common emitter amplifier, the output is measured at the collector terminal and the gain is a negative value. In this course, we will cover 3 types of common emitter. First, emitter grounded. Second, emitter with Re. And third, with bypass capacitor CE. To solve AC signal in common emitter amplifier circuit, we can follow these steps. We start with the output side. At first, we need to get the equivalent resistance at the output side, Rout. Secondly, we get the Vout equation. Here, Vout is equal to minus GM-VBE times Rout. Then, we move to the input side. Thirdly, we need to find VBE in terms of IB, and this is followed by calculating RIB, which is the input resistance seen from the base. RIB is equal to VB over IB or VBE over IB. Now we calculate Rin and we get the VBE in terms of Vs. And finally, we go back to the Vout equation and replace where necessary. Let's try one example. Given in the figure is the common emitter circuit with emitter grounded. Find the AV voltage gain and AI current gain of the circuit given. Note that in this example, the early voltage is given, hence we can predict that there will be an RO at the collector emitter terminals. Solving the DC value, capacitor needs to be open circuit and turn off the AC source. It is a voltage divider biasing and we need to find the IB. Once we obtain the IB value, we need to determine the AC parameters Rpi, Gm, and Ro. For the voltage divider biasing, we need to find the Thevenin equivalent circuit of the input BE loop. VTH is equal to R2 over R1 plus R2 multiply with VCC and RTH is equivalent to R1 parallel with R2. Then solving the BE loop to find IB. The KVL of BE loop is 5.9 times IB plus 0.7 minus 0.756 equal to 0, and from there IB is equal to 9.49 microampere. From there we can find IC, which is beta IB, and IC is 0.949 milliampere. From there we calculate the small signal parameter. R pi is equal to 2.74 kilo ohm, RO is 105.37 kilo ohm, and GM is 36.5 milliampere per volt. Now it's time to draw the AC equivalent circuit for the CE amplifier circuit. It is recommended that we start the process by replacing the BJT with the hybrid pi model. Draw the R pi between base and emitter terminals and a dependent current control source GMVBE between collector and emitter terminals. Due to the early voltage given in the example, we must not forget to include the RO, which is in parallel with GMVBE at CE terminals. Then we can proceed to complete the rest of the circuit. At the base, the resistor connected is RTH, that is R1 parallel to R2, and note that the VTH is grounded because this is AC analysis. Next, the coupling capacitor is short circuit. Draw the RS in series with the RTH, and finally the AC supply voltage VS and then ground. At the collector terminal, draw the RC and then ground because VCC is short circuit in AC and then straight to ground. With that, we are ready to determine the amplifier parameters such as the voltage gain AV and current gain AI. By following the steps given previously, we start by finding the R out at the output terminal. Here, the R out is RO parallel with RC, and this is equal to 5.677 kilo ohm. Second, we write the V out equation. V out is equal to minus GMVBE times R out, and R out is RO parallel with RC, and this is equal to minus 207.19 VBE. Note that there is a minus GMVBE for the V out equation, and this is because the direction of the current, which is the opposite the dependent current control source at the collector emitter terminals. Then we find the VBE in terms of IB. Writing the KVL at the input loop, IB R pi minus VBE equal to 0, and therefore VBE is equal to IB R pi. Here, the VBE is equal to 2.74 IB. Now we calculate RIB, which is the input resistance seen from the base. RIB is equal to VB over IB, and this is equal to R pi, which is 2.74 kilo ohm. Next, we calculate Rin, and Rin is equal to RTH in parallel with RIB, and it is equal to 1.87 kilo ohm. Using voltage divider, we can write VBE in terms of Vs. VBE is equal to Rin over Rin plus Rs times Vs, and this is equal to 0.789 Vs. So if we substitute VBE equal to 0.789 Vs to the equation of V out, where V out is equal to minus 207.19 VBE, we get V out equal to minus 207.9 times 0.789 Vs, and from there we can get Vout is equal to minus 163.5 Vs. From there we get the voltage gain Vout over Vs equal to minus 163.5. The minus at the voltage gain refers to the 180 degrees out of phase output voltage from the input voltage. Now we derive the current gain. At the output side, Iout is equal to Vout over Rc, and this is equal to Vout over 6 kilo ohm. At the input side, Is is equal to Vs over Rs plus Rin, and this is equal to Vs over 2.37. Therefore, the current gain Ai is equal to Iout over Is, which is equal to Vout times 2.37 over Vs times 6, and this is equal to minus 163.5 times 0.395, and the current gain is minus 64.6. We can see that to get current gain Ai, we can also use voltage gain. So to get current gain Ai is AV times Rin over Rout. I hope this video will help your understanding on how to solve common emitter amplifier parameters such as AV and Ai. Thank you for watching.